Hello AP Statistics, sorry I cannot be with you today, but here are the notes for section 10.1. Remember that we are reviewing tomorrow and that you have a test on chapter 9 on Thursday. So chapter 9 was all about confidence intervals, which I told you we will be doing all of this semester. Chapter 10 is about hypothesis tests, which again we will be doing all of this semester. So chapter 9, we tried to write an interval for a population parameter. So we tried to give an interval for the population mean or the population proportion. A hypothesis test is about testing a claim. So today's objective is we will be able to write null and alternative hypotheses with given problems in a context. So this is kind of the background for hypothesis tests. This is the first step in a hypothesis test. In a hypothesis test, we're going to be testing a claim about that population parameter. So do I have evidence that the population mean is greater than 10? Do I have evidence that the population proportion is greater than 0.5? So first to look at just the structure of a hypothesis test, we always have a null hypothesis. So that HO is a null hypothesis, like NULL. So in a court of law, we always assume that the defendant is not guilty. So the null hypothesis is always the assumption. And then we have the alternative hypothesis, and that's what we look for evidence in favor of. So in a court of law, we look for evidence that the defendant is guilty. So anytime someone comes into a court of law, they're assumed to be not guilty. And then it's up to the plaintiff to prove that that person is actually guilty. So we take evidence, assume that the person is not guilty, and look for overwhelming evidence beyond a doubt that the person is guilty. If that's the case in a hypothesis test, we reject the null hypothesis and instead believe that the evidence supports the alternative, supports a guilty verdict. So we say beyond a reasonable doubt, the defendant has to be guilty. You know, we highly doubt that the person is not guilty. Okay, so again, we always assume that the person is not guilty. That's the null, always what we assume to be true. Alternative, the defendant is guilty. That's what we look for evidence in favor of. Sometimes in a court of law, we assume not guilty, and the plaintiff only shows a little bit of evidence. And so you on the jury, you think, well, the person could be guilty, but there really wasn't enough evidence to say that the defendant is guilty. In that case, we fail to reject the null. We say there's not enough evidence to call the defendant guilty. So we did not prove that the person wasn't guilty. We did not prove innocence. So the person is always assumed to be not guilty. You never prove that. The only thing that's proven is being guilty. We cannot prove the null true. That's really important. That's why it's big in red. We can never prove that the null is true. We only say that there's not enough evidence for the alternative. So we have no reason to doubt the null. So in a court of law, the defendant is either not guilty or guilty. We never prove the defendant innocent. In a hypothesis test, the null, we either fail to reject or reject. We never accept the null. The null is always what we assume to be true. We never, ever accept it. You always look for evidence in favor of the alternative. So this is what a problem on your homework is going to look like. It says a certain TV station has been providing live coverage of a particularly sensational criminal trial. The station's program director wishes to know whether more than half the potential viewers prefer a return to regular daytime programming. A survey of randomly selected viewers is conducted. Let pi represent the true proportion of viewers who prefer regular daytime programming. What hypotheses should the program director test to answer the question of interest? Okay, so I told you we always have a null hypothesis. That's the HO. This case, we're using pi. The null is always in terms of equal. It's always going to be equal no matter what. The director wants to know if more than half. So we're going to assume that pi is 0.5. If pi is 0.5, that implies not more than half. So not more than half prefer a return to regular daytime programming. Okay, so that's our null hypothesis. The other one is called the alternative hypothesis. That's HA. This is what we care about. The director wants to know if more than half prefer a return, so we're going to look for evidence that pi is greater than 0.5. If pi is greater than 0.5, that implies that indeed more than half prefer a return. To regular daytime programming. Okay, so this is all that section 1 is about, is writing the null and the alternative hypotheses. We're not actually going to test them yet. We're not going to do that until section 3. Just an important note. The null is always in terms of equal. The alternative can be greater than, less than, or not equal to. So I have one more example for us to do. Okay, many older homes have electrical systems that use fuses rather than circuit breakers. A manufacturer of 40 amp fuses wants to make sure that the mean amperage at which its fuses burn out is in fact 40. If the mean is lower than 40, customers will complain because the fuses require replacement too often. If the mean is higher than 40, the manufacturer might be liable for damage to an electrical system as a result of fuse malfunction. To verify the mean amperage of the fuses, a sample of fuses is selected and tested. If a hypothesis test is performed using the resulting data, what null and alternative hypotheses would be of interest to the manufacturer? Okay, so first one, null, or HO. Remember that this one's always equal to. We are looking at mean amperage. So mean, that means mu. We're going to assume that these fuses properly function, so we're going to assume that the mean is actually 40. In this case, the fuses burn out at 40, at an amperage of 40. So I'm going to say the mean amperage is 40. The fuses are functioning properly. Then the alternative okay, so it says in the problem that the manufacturer does not want the fuses to burn out over 40 or lower than 40. So we want to know if the mean is not 40. So if the mean is greater than 40, then there could be damage to the electrical system. If the mean is less than 40, then the fuses require replacement too often. So if the mean is not 40, the fuses are not functioning properly. Okay. So that's all of section 1. Section 1 is just about writing the null and the alternative hypotheses with a given context. So what you need to do when you do a problem in your homework is you need to write the null and the alternative and then what they mean to us. So in the last problem, the mean being 40, that told us that the fuses were working properly. The mean not being 40 told us that the fuses were not working properly. That's what it means to us. Remember to always use context. Right now, what I would like you to do, in your packet, I want you to go to this page, I believe it's page 9, maybe, and do pages 9 and 10. So it's A, B, and C. There will be an answer key at the front of the room. Do all 3 parts, then come check your answer. I will be checking this tomorrow. Once you're done with that, please start working on homework 1 from chapter 10. That is due on Friday. I think it's only 5 problems. So again, work on the AP problem in your packet. When you're finished with that, work on homework 1, please. Thank you, and see you all tomorrow.